Well, hello to all my honors and gifted geometry students. Actually, hello to Dr. Esfiedo's or Miss Grasso's students as well. I really miss all my students and I wish them a big happy mwah, because I hope to see you soon. I hope you're all healthy and safe. Just a few announcements to start with. Obviously, you need to check eCampus every Monday or before, so you know what we're looking at for the week. We are streamlining our knowledge of geometry from here until we return so that we don't overwhelm you. So please give us input on that. Look at the announcements. We are going to be looking at doing a discussion for some points this week. So that just means you need to put something in the discussion. Please do use the appropriate teacher when you do that so that you get your points. Other information there this week, we're basically going to be looking at two sections. I'm going to give you an overview of 10.4 and 10.5. We're going to use the homework like we're used to right from the homework audits. So you can look at the homework audit for chapter 10 that you should already have. If you don't have it, and obviously in chapter 11 you won't, these all can be found on eCampus. So please go ahead and print those off. We will not be doing the workbook problems or the challenge worksheets, so that'll help you with time management. So just the textbook problems. For this week then, the textbook problems from 10.4 and 10.5. I think everything else is pretty self-explanatory. I will be looking at doing my time from 9:30 till 1:30 every day. So if you could give me any input on that, that would be great. So I'll be online then or available at that time. I'm trying to find my phone number. So if you have any questions, you can get those answered. Here it is. The number you can call me at any time between 9:30 and 1:30 daily, Monday through Friday, is 386-516-0491. Okay, and I think that's about all we have. So discussion this week and the two homework assignments. Oh, you do have an option of doing your reteaches or your PowerPoints. So some teachers use PowerPoint, some teachers the reteaches. So whatever you're used to, those answers will be posted also in the video section on eCampus. So look at those and have that with you when you check in. So you'll need both homework assignments and your either reteaches or your PowerPoint. So you don't have to do the whole reteaches, just the ones that are on the video. Okay. Oh, here's the problem with all this online learning is you never know when these pets are going to come around. That was my pet rabbit. And he reminded me that some of you didn't hear the end of the story from a few weeks ago. And the question was, why was 69 afraid of 70? Well, why was 69 afraid of 70? They had a fight, and 71. You'll laugh about that later. Okay, let's get started. We are looking at 10.4 here first. So if I can slide this around so you can do a few notes here. 10.4 really could be put in with 10.3 as it's really working with the same thing as 10.3. It's on area and perimeter in a coordinate plane. 10.3 definitely was working with composite figures, and that's really what you're going to be doing as the new part of 10.4. The old part of 10.4 is obviously the perimeter. Well, that's just going to be the distance around, and if you have a coordinate, you're going to end up using the distance formula. So don't forget that good old distance formula, x1 minus x2 quantity squared plus y1 minus y2's quantity squared, and the square root of all of that. Okay, so that's all you would do to find the lengths of each of those segments and then just add those together. So perimeter really isn't new at all. Now for the area, if the shape is a square, then just use this formula for a square and just take one side and square it. But in this case, we don't have a square. We're trying to find the area of this quadrilateral, so it doesn't tell us that it's anything special, this quadrilateral KLMN. So the first thing is graph it so that you can see whether it is a special quadrilateral or not. Once I have it graphed, then what we're going to do is make it into a composite figure. We're going to do that by adding vertical and horizontal lines. And that's the key to this lesson, is making all vertical and horizontal lines. So I'm touching each one of those points and saying I'm putting in vertical and horizontal lines going through those points. So you can see that I'm making it go through this point and through M, okay, through every single point. So essentially what you're doing is what you had in the composite figures now. You're going to find the area of your rectangle and subtract out your 3 triangles. So that's really the new part. So not too bad at all. So now we're looking at the area of the rectangle. How am I supposed to do that? Well, the area of a rectangle is just base times height. So I just count and I find out that that is 8. And I count from -6 to +6. I find that is 12. So of course my area is 96 square units. So that's fairly easy. Then I just do the area of a triangle. And just like you said, it's going to be 1/2 base times height. Because it's a rectangle, each one of these angles will be 90 degrees. So again, all I'm going to do is count and realize that I have 6 by 8 here, and, or excuse me, 6 by 4 here. And 8 by 6 here for my triangle, a 2 by 2 here, and a 10 by 2 down here. So I just use the 1/2 base times height for each one of those, and I find that my areas of my 4 triangles are 12 square units, 10 square units, 2 square units, and 24 square units. And now you can imagine we're almost done with the problem, because at this point then we're simply going to say we're going to take the whole area of 96 square units and subtract the 22, 24 plus 24, the 48 square units for the triangles. So my answer would be 48 square units. That is my area. Now that is the more complicated, and I started with that first so that can kind of sink in. But you could have done this a lot easier in this particular example, and that's why I picked this example. You could also say, oh, well, why not just make this with one horizontal line here into 2 different triangles, and then simply count your base and your height, count your base and your height, and you would end up with the same answer of 48 square units. So find the easiest way. You know me, I like to find the easiest way to do anything. And I will give you some more examples on the reteach video that I have. It's actually a PowerPoint, okay? Now, let's move on to 10.5. Oh, he wants to be introduced. Boo! No, he doesn't. He's going away, huh? 10.5 is actually a lot easier, because 10.5 just goes and puts 2 things together that we've had from before. And that is 10.5 is effects of changing dimensions proportionally. If the figures are similar, you are definitely just like you were before in saying, oh, I'm just going to use the perimeter or circumference ratio and say it's the same as the similarity ratio. If they are not similar, or excuse me, if it's the area ratio, don't forget you have to square it. And if they're not similar, then you have to do a little more thinking and use the appropriate formula for whatever it's talking about. So that's basically 10.5, is just decide if they're similar or not similar, because you're going to do a lot more work if you have similar figures and you don't have to do all that work. For example, if I said I have a circle that has a radius of 3 inches, and then I quadruple the radius for a larger circle, and it wants us to find the area of the larger one, well, all I have to do is use the area ratio. If it's 4 times bigger, then I know it's going to have 16 times the area. So I take the area of the first circle, multiply by 16, and I'd be done. Okay? So just remember, like we did with similar figures, check to see if it's similar. And remember, similar figures have to have the same dimensions, growth on every dimension. So if it's just the height that's changing or if it's just the width that's changing, it would not be similar. It has to have every dimension changing the same. So similar figures or not similar figures. So let's take a look at one that is not similar figures. Okay, and let's just put it right on top of that. Okay, so our only example here is going to be a square has a side of 5 centimeters. What happens to the side length if the area of that square, the larger square, is tripled? Okay, so let's take a look at that. Well, if a square has an area of, or a side of 5 centimeters, then obviously it's a square. It would have an area of 25 square centimeters. Okay, and then I'm looking at saying what happens to the side length if the area of the larger square is tripled. So if I tripled the area, it was 25, that would mean the area here is 75 square centimeters. Okay, so now I know that these sides have to be the same, so I'm really just saying what times what is equal to 75. So a little review on remembering to take the square root and simplifying it. So we want exact answers. So you would end up saying x is equal to 25 times 3, or one side is 5 square roots of 3. Now I picked that to show you both examples because I could do it just using the formulas, and that's what I did here. Said, okay, I'm just using the formulas and saying so therefore I'm just going to take this and use the formula and say I'm going to find the area of the square, and I just used the squared. But think about it, aren't all squares similar? So I could have done this a lot easier. If I say that the area ratio is tripled, then I could say area ratio, we'll use the simplified, is 3 or 3 to 1. Okay, so that means then that it started out with the similarity ratio as the square root of 3 to 1. Well, take a look at that. Isn't that what we did? The length was 5, so every length ratio is going to be the square root of 3 times as long. So that's what I'm talking about, is look in that section in 10.5 and see if they're similar or not, because if they're similar, you can save some time. Again, the video, the next video or the next PowerPoint with the reteaches will give you more examples. So if you need any more examples, please take a look at that. But I just wanted to give you a heads up on how this is just an extension to finish out this chapter. So I hope you think it's easy. But if you don't, remember, you can always come get help. I think this is going to be a great opportunity for those of you that are very good and quick at learning. And if you need more help, there is plenty of time to get help. So please, I encourage you, check in. And remember, even if it's easy for you, everyone needs to check in. So you can check in as often as you want. This week I need a discussion post, okay? I need the reteach or just, you don't have to do both, the reteach, just the problems I did, and there's not that many, it won't take that long, or the notes, the PowerPoints. So whichever way you're comfortable with, use the one that you're used to doing. And then the other way you can get points, you need to have your homework done. So I'll be looking for those things. You can take a picture of them and email them to your teachers. You can do a webcast or whatever, WebEx or whatever you are comfortable doing. So we will be learning this together. I hope that you see a little bit of an overview of 10.4 and 10.5. Have an awesome day.